This video covers D3 scales for data. The structure of this video is as follows. D3 scales revisited. D3 axes component revisited. D3 scales for data, and the summary. Alright, let's get started. D3 scales revisited. D3 provides three types of functions that map an input domain to an output range. The quantitative scales are for real numbers. The ordinal scales are discrete domains such as letters of the alphabet. And the time scales are an extension of the quantitative scales that use the JavaScript date objects. All of these scales take in data and convert it to a usable set of output. D3 quantitative scales are for continuous input domains such as numbers and time. The mapping is linear in that the output range y can be expressed as a linear function of the input domain x. So we get y equals mx plus b. Rather than having to do this math ourselves, we can get D3 to do the math for us. Using the D3 scale linear, we can tell D3 that the initial data covers 0 to 400 and we want it to cover 0 to 200 after it has been scaled. This then figures out the correct math for the y equals mx plus b equation. The initial data is entered in the domain, and what we want the data to be scaled to is put into the range. The domain is line 1, the range is line 2. The range is thus the result of the y equals mx plus b transformation from line 1 to line 2. The leftmost element in line 1 gets transformed to the leftmost element in line 2, and the rightmost element in line 1 gets transformed to the rightmost element in line 2, and the middle elements in line 1 get transformed to the middle elements in line 2. D3 axis component revisited. The D3 axis component displays reference lines, label ticks, and does the math to get equal space between the ticks for any scale we provide automatically. The D3 axis component works with quantitative scales, time scales, and even ordinal scales. This is the most basic way to add an axis to an SVG container. Notice that we use D3 to create the SVG container. Then we add the width and height attribute to the SVG container. Then we append an SVG group element. The SVG group element will hold the D3 axis elements. Finally, we call the D3.svg.axis component. We have to call the D3 axis component to add the D3 axis to the SVG group element. The D3.svg.axis component is a function, so when we call it, we are passing to it the current selection. The current selection being the SVG group element. The SVG axis component does its function thing and then returns a new selection. Given D3 margin convention, D3 scales, and D3 axis components, we can put together this code to give us an inner drawing space in an SVG container that has the well-defined x and y axes. The axes take into account the scale domain of the data we wanted. The axes also take into account the width and height of the inner SVG drawing space to make sure the axes cover the full width and height. What is left to figure out is what to do and how to manipulate the data that will go inside. D3 scales for data. In the code before, we used this to set up the D3 scale function. We told it that the domain of the data was 0 to 10 and that it should be mapped to a range of 0 to the width, which in this case was 200. Recalling how to think about the domain and range, where the domain is line 1 and the range is line 2, the data that we have lives on line 1, which means that if we want it to be represented in the scaled version of the world, which is line 2, we also have to convert it using the scaling function. In D3 data visualizations, there are usually two main places where we touch and/or manipulate the actual real data. 1, when we define the data source. 2, when we tell D3 how to find the data that is bound to the DOM elements. So if we are going to use a scale to manipulate the actual real data to fit into the scale world, we have two choices for where to manipulate the data. It is really not a choice. Once you receive or define the real data, leave it alone. There may be more than one process that needs the actual real data rather than the scale data. which means that if any scaling of the data is going to be done, it should be done when we are taking the real data that is bound to the DOM element and scaling it for the attributes of that element. This makes sure that the real data is attached to the DOM element. However, the attribute data is the data that is scaled. This is scaled to match the type of scaling that we want to happen in the data visualization. Most of the time, this means fitting inside of the SVG container and SVG inner drawing space we have defined. Let's take a look in the JavaScript console. First, we enter all of the code necessary for the SVG viewport, the SVG inner space, and the SVG function. Then we generate the scale, which will be used for both axes elements as well as scaling the data later. We define the x-axis and the y-axis functions, scale them, and give them an orientation. Next, we define the SVG viewport as well as an inner drawing space. Next, we call the x-axis and y-axis functions to have them generate all the D3 axis components. And there we go. We now have the full chart ready for us. Next, let's define a data object to pass to the D3 data operator. Next, let's bind the data to an SVG circle element. You can see that the circle SVG element was added to the G group that has the transform translate. This G group is the inner drawing space. The circle was added as the last child element because this is how the D3 append operator works. The circle does not appear on the screen because we have not defined its attributes. First, let's define its attributes without scaling the data. The attributes are defined based on the data that was bound to the SVG circle element. We use anonymous functions to get out the relevant x and y values. We set the radius to be 5. When we press enter, you can see that the circle was created. If we look at the elements section of the Chrome Developers tools, we see that the CX is 5, the CY is 5, and the radius is 5, which is what the data told us. However, when we look at the chart in the web page, it currently looks like the circle's data has a CX of something between 0 and 1 and has a CY of something between 0 and 1. This is because we did not scale the data when we defined the attributes of the circle. Let's delete the circle SVG element inside of this transformed translated G element to clear the drawing space. When using Chrome Developer Tools, you can delete elements right from this window. Just click on them and then press the delete key. As you can see, the circle element is no longer there. Let's bind the data to the SVG circle element and create the circle element again. You can see that the circle SVG element was added to the G group that has the transform translate. This time, let's define its attributes, making sure to scale the data using the scaling function. The attributes are defined based on the data that was bound to the SVG circle element. We use anonymous JavaScript functions to get out the relevant x and y values. We set the radius to be 5. This time, however, we use the scaling function to scale the real data to a scaled version of the data. This scaled version of the data will match the scaling applied to the x and y axis. When we press enter, you can see that the circle was created. If we look at the elements section of the Chrome Developer Tools, we see that the CX is 100 and the CY is 100 and the radius is 5, which is what we would expect given that we use the scaling function. The scaling function took the numbers in the domain and multiplied them by 20 to get the range. So the CX equals 5 and CY equals 5 from before have been scaled to CX equals 100 and CY equals 100, which is great because now the graph axis and the data plotted on the graph actually show the same thing, that the data point has an X value of 5 and a Y value of 5. And with that, you can see just how easy and useful it can be to scale the data when setting attributes. It helps to make sure that the data attributes are scaled in the same way that the axis attributes have been. The D3 scale function does all the math behind the scenes as long as we provide for it a scale with a domain and range. The summary. This video covered D3 Scales Revisited, D3 Axis Component Revisited, D3 Scales for Data, and the summary.